Today we'll be looking at a synthetic dataset generator using GPT-4, which generates an entire dataset to fine-tune GPT 3.5 or any other open source model such as Llama 2 using a simple dataset prompt. We are able to adjust the number of examples and try to adjust the total examples per topic. We attempt to keep track of different topics and how many examples each one has been generated for. Here in this example, we are generating a dataset of Python functions. Not only that, but we are also saving each sample with its embeddings to a JSON file and also to a CSV file with embeddings. We are also saving each file as a .py file, so you can have all the creativity you need. I have already generated over 700 examples of Python functions, which you can use to train, fine-tune GPT 3.5, the code files, and the dataset, along with their embeddings, and each individual file will be available at Patreon. Link is in the description. Let's quickly run this and see how it works. We will be generating 100 examples. We are using thread pool executor, so we will be generating each data element item in parallel. Now, the first thing to notice is this warning message. If system message dataset.txt exists, system message will be loaded from there. It is this file right here. This is to ensure that if you want to continue generating your dataset bit by bit, we are saving it to a file to load it from there. Since we will be generating from scratch, we will just delete that. Our dataset prompt is a model that takes in a prompt in English for a Python function and responds with the simplest, smallest, fully functional, most efficient Python function that satisfies the prompt. So we are just going to click enter. We have deleted the previous system message for our dataset. And now we have generated a new dataset because we have deleted the file. This is our system message for the dataset. Given a description of a Python function in English, generate the simplest, smallest, fully functional, and most efficient Python code that satisfies the description. We will accept this. This system message will be going into each one of the dataset elements for the model to be fine-tuned. And we are generating currently covered topics and diversification direction because we try to diversify the topics as much as possible. That's why we are keeping track of which topics we're covering and how many times we have covered them. And then, as you see, also we are writing each one of the generated items into a dataset with the system message we have just generated. And the user content is automatically generated, and also the assistant content is automatically generated. So this will continue for a while. We are employing 10 workers in parallel with thread pool executor. The beautiful part of this approach is that you will actually not generate any much repeats. I mean, you will be generating some repeat content because we are actually saving all these to a data frame ahead of writing to file, and we are removing duplicates. So I was able to get in the early stages of data generation about 95% unique content, and in later stages almost 80 to 90% unique content. Each generated item is being saved to our fine-tuning dataset.jsonl file, which you can use directly to fine-tune GPT 3.5 Turbo. Also, we are saving them to a dataset with embeddings.json file with their embeddings, and also to a CSV file as well. So along with saving them to each function file, .python file. So each function is saved separately. So you'll have full creative control. We are actually done. And as you see, we were able to generate 96 unique examples for our dataset from the original 100 unique examples that were intended. Let's now move on to reviewing the code. But before we do that, I do want to mention this project cost me almost $100 in testing and dataset generation. I will be making the code files available at the connoisseur level at my Patreon, and the code files and all the data files at AI architect level. When you do show support by becoming a Patreon member, then I am able to create more complex projects which cost a lot more in API usage. When you become a patron, then you not only will be supporting me, but will also have access to 120 plus project files that you can download and use yourself. And also you will have access to office hours and will be able to chat with me. Link to the code files, the dataset files, and my Patreon will be in the description. We will be using LangChain OpenAI embeddings to embed the documents concurrent futures to do parallel processing. Requirements for these are listed as such. We are doing some logging for Tenacity. We will be using Tenacity to retry our OpenAI calls just in case if they fail due to rate limit errors or something like that. We will be waiting for a maximum of 60 seconds, 10 times with exponential backoff, waiting longer with each retry. This is our embedding function, which we will use to embed each item that is returned to us for our data set. Then we have our generate system message, which we'll be using GPT-4 for. This will generate a system message for us. This system message is the system message which will go into each one of the dataset items. Our dataset prompt is a model that takes in a prompt in English for a Python function and responds with the simplest, smallest, fully functional, most efficient Python function that satisfies the prompt. Here in these two prompts, which we are combining right here, we are defining a model which we will be fine-tuning. So with this, we are telling GPT-4 to generate examples for this kind of model, a model which takes in a prompt in English and generates Python functions. We are doing it in two parts. The desired response goes at the end of the dataset prompt because we are using the desired response prompt down here at the function definition. We will be explaining all that shortly. So in essence, the generate system message generates a system message which we will be putting into our fine-tuning dataset JSON-L file. Each one of these entries will get this system message, which is the system message for the model, which we will be fine-tuning. And the dataset prompt, the complete dataset prompt, will actually prompt the GPT-4 to produce the dataset, defines the model which we will be producing the dataset for. We are setting our model to be GPT-4, temperature to be 0.4. We are initializing an empty topics count dictionary. We are starting with number of examples 100 and total examples per topic to be 10 because we are going to attempt to produce as many varied topics as possible. The first part is the generation of the system message. We use the generate system message function. If there is no system message dataset.txt file, then we will generate one, ask the user if they like it, then save it to a file. The reason for that is instead of going overboard right away, like with 1,000 number of examples or something like that, with this approach, you can actually have an iterative approach. For example, generate your dataset 100 or 200 items at a time, if you like. As I said, you can use this dataset to fine-tune GPT 3.5. Or for any other open source model, you would just have to change the schema according to the model that you need. Currently, it generates for GPT 3.5. Once our system message is generated, then we load from our CSV file, if it exists, or our embeddings, and then create a runtime.df. Our data frame is going to include a prompt, response, and embedding columns. If we don't already have embeddings file, then we initialize it. Then we have a function which updates the topic counts. GPT returns to us the current topic it wants to cover for each item, dataset item, and then we keep track of that and write it to the topics count.json file and how many times, as a matter of fact, those items were covered, as you see. For example, string manipulation here was covered twice, date time was covered twice. Our next function is the crux of this whole program, which is the generate dataset. It takes in the dataset prompt and the model. Our base message is explaining to GPT-4 that it is generating a diverse dataset which will be used to train a machine learning model. At the end of this prompt, we are entering the dataset prompt, which is to say that the model we want to train, the type of model we want to train is defined in the dataset prompt. Remember, back up here, we were defining the dataset prompt. And the reason why we were splitting it into two parts is because we are going to be inserting this part into the function definition. So this is our system message, which will generate the dataset. We are entering total example per topic here, like this, generated total max of that many examples for a topic category, attempting to get GPT-4 to diversify, but also limit the number of examples per topic. It doesn't follow this perfectly, but this definitely helps the model. And then we are inserting a new instruction as the role user. We say make sure to diversify each new example from the examples that are already in the data set as follows. And then we insert the topic's content here from this JSON file. And then we add an assistant message saying diversify in a direction than most covered topics. Add to less covered methods to create a bias-free distribution. Here are the topics covered so far. And we insert the topics content right here. Then we combine all three messages, the base message, the pass prompt instructions, and the assistant message as the messages, and then we make our call with a streaming true response. So we can choose to print streaming responses to terminal. Before I continue, I was inspired by Matt Schumer's GPT LLM trainer repository. I made quite a few improvements on it, but I'll be putting the GitHub repo link in the description. So then we are defining our function definition, because we'll be calling a function call. We call the name of the function, supposed function. We will not be calling a function, but this is our way of getting structured data out of GPT. Name of the imaginary function is dataset item. Its description is a dataset item, is a prompt response pair. And then we are now defining the parameters. Our first parameter is the diversification direction, with the description as a detailed description of a more complex and diverse topic to diversify to, which is different from the topics covered so far in the dataset. So we get the model to decide on a topic. Then we get a prompt from it for our dataset, the diversified prompt to generate a response for. And then we wanted to generate a response for this prompt. And then we insert desired response prompt here. As you remember, we have defined this up here. The simplest and smallest, fully functional, most efficient Python function that satisfies the prompt. So the prompt is what GPT generates, and the response is also what GPT generates based on our dataset prompt. Now, hopefully you understand why we split this into two. We do add this to the end of the dataset prompt like this. I have zoomed out so you can see it more clearly. We add the desired response prompt at the end of dataset prompt. And then we define another parameter called current covered topic, and this is to return topic of the example currently being generated. So diversification direction attempts the model to come up with a more diverse topic, then generates a prompt for it and a response, and then it returns whatever it's covering currently. We do require all these to be returned, and we do force GPT to call the database item function call. Then we initiate our streaming responses parsing. I have commented out this line. If you comment this in, then you will be seeing the streaming responses printed. Then we return the responses. Then we have a function called generate example, which takes in the dataset prompt and the model name, and then generates the dataset, which is the function that we have defined up here, which makes the call to GPT to generate the dataset one by one. Then we get its response, and we try to parse each one, the new prompt, new response, diversity direction, and currently covered topic with the JSON.loads. And then we use update topic counts function, which we mentioned a little bit above, to update it with the currently covered topic. We print it, and then we print diversification direction. If these JSON.loads fail, we simply print it so that our program doesn't crash. Then we have a combined response, which we are combining the new prompt with a hashtag in front of it with the new response, because we want to embed them together. Also, we want to write each one to a file. If you're not dealing with code, you can feel free to remove the hashtag from in front of this. Then we create a dataset files if it doesn't exist, and we write every generation to a file as well. And then we return the new prompt, new response, and the combined response. The new prompt and the new response is each item that is going to be in our dataset. And then we have a generate data frame function, which takes in the dataset prompt and the model name. which calls the generate example function, which is this one, which calls the generate dataset. And then we retrieve new prompt, new response, combined response, which was returned here. And we check if we have a new prompt and new response. We generate a data frame with the prompt, response, and embedding columns. And then we assign to the embedding columns with the get embedding function, which we define using LangChain, the embedding of the combined response. So now we will have a data frame with these three columns. And then we return it. We do use threads lock functionality because when we are doing parallel processing, we do need to use this. So because we are writing into a lot of files and we don't want to get caught in what's called a race condition. I know this is a pretty complex set of actions that are taking place, but we're almost at the end. And next we have a save the files function. It saves the data frame to various file formats. We did have our runtime DF, which we will be using. And then with the file lock, which we have initiated, we first drop everything that is duplicate, only keep the rows in the new DF format that are not already in the runtime DF, because we don't want to have duplicates in our dataset. GPT-4 can sometimes generate duplicates, so this is why we're doing that. So to keep track of the topics, and also to have all the diversification elements in the function call is to create as diverse of a data set as possible. Then we make sure that data frame is not empty. Then we update our data frame, and now it should be free from any duplicates. And then first we're going to save it to a CSV file, just like this. If we don't have the file, then we're going to generate it. Then we're going to save it to a JSON file, just like this. If it doesn't exist, we're going to create it. Otherwise, we're appending to the end of these. The reason why we're saving it to CSV and JSON, because it's just a preference issue. CSV actually saves the embeddings as a string. When you're loading the embeddings from a CSV, you have to convert it back to a list. JSON, I believe, doesn't have that issue. If you download these, you'll have access to both anyway. And then next is the most important part. We are going to be saving our fine-tuning dataset.json.al file. Here, we are saving it for GPT 3.5 Turbo, but feel free to modify this to the kind of model which you want to fine-tune for. Here we are going to iterate over our data frame, and we are going to create the schema as messages list with the role system is whatever our system message data set is. Remember, this is what we have generated in the beginning and saved into this file. And then role user is going to get the prompt, and the assistant is going to get the response, which is going to create our data set as a messages list, each one having a system message, user message, and an assistant message. This is it. Then we write over that, and then we have a process and save function, which just calls the generate data frame and save the files. And then we have run with thread pool. This is our parallel processing function, which calls the process and save. So each one of these functions is calling the one from one before, as you have noticed. We have max workers set at 10. Feel free to increase this. If you want to run this, not in parallel, but if you want to see what's happening sequentially, you can set the max workers to 1 to simulate sequential running. Be careful, this can be a costly process. If you set max workers higher, the process should complete faster. But if you set very high number of examples here, then make sure that you know what you're doing, because this process do cost a lot of tokens. Like I said, this entire project cost me about $100, and the dataset files, which I'll make available at Patreon, cost me about $50. As I said before, I'll be making the code files to run this so you can generate your own datasets, or you can also download the complete dataset along with the topics count, the fine-tuning dataset, which is over 700 Python function dataset ready to train GPT 3.5 Turbo. I also have all the data with the embeddings, both in JSON and CSV files. And also each one of these dataset entries is saved into its own file. This was a quite complex topic, and I hope I did some justice. I tried to explain it as clearly as possible. Please let me know in the comments or at the Discord server if you have any questions about it. The topics count can be improved because as the topics counts grow, this gets inputted into GPT and then it increases the cost. I have an idea to actually make this process better and cheaper. I'll be making a video on it when I get it working. Make sure to join our Discord if you like to talk about these types of topics. We have over 700 members. The link will be in the description. Also, if you join my Discord, like I said, you'll be able to download all my projects files, including 120 plus projects. You'll also get the chance to talk to me in the office hours. The next upcoming office hours is this coming Sunday. You can also quickly search all my videos and browse through them and find the code download links at www.echohive.live. Thank you for watching. Let me know what you think, and I hope you'll make good use of the dataset and the entire program. You can actually make this work for any type of context. Just make sure to change the dataset prompt and the desired response prompt accordingly. And make sure when you're generating system message from scratch to delete the system message dataset.txt. Take care and see you in the next video.